Hello there. In this video, we'll be talking about metadata. So, what is it actually? In simple terms, metadata can be referred as data about data. A more exact definition of metadata, however, is a description of data, containing specific information such as the type of data, length, textual description, context of data and other characteristics. It can be described as a single piece of data, a dataset or collection of data, or both physical data and digital data. An example of physical data would be card catalogs in the library. As for digital data, an example is a document file consisting of the author, date created, date modified, and file size. Metadata is categorized according to its function, hence there is a variety of types of metadata. However, there are three main types: descriptive metadata, structural metadata, and administrative metadata. Descriptive metadata shows specific characteristics of a piece of data. It is used for discovery and identification, including information such as author, when it was made, what the content is, the size of the file, keywords, song titles, volume numbers, and more. Structural metadata shows the design and specifications of data structures. This type of metadata indicates how information of data should be categorized. It is often used in media content, describing how pages in a book should be organized to form a chapter. Administrative metadata refers to the information about the origin of the resources, their type, and access right. For example, a Creative Commons license. As the world progresses, information has become more digitalized, making the quality of the original data increase. Therefore, making metadata serving a variety of purposes. One purpose of metadata is discovering and organizing data. Metadata helps you discover data, understand data relationships, track how data is used, and assess the value and risks associated with its use. It can be compared to effective cataloging, which includes identifying resources, classifying data according to its criteria, as well as highlight missing, incorrect, or any unnatural data. It can then help improve the quality of analytics, where the data behind a report is automatically corrected and enriched to improve decision-making and avoid costly mistakes. It is also used for facilitating interoperability and integration. Using metadata to describe data helps to understand the logical and physical aspects of data. This grants the most effective levels of how data is exchanged among many systems with various operating platforms, data structures, and interfaces. In turn, it simplifies data searches across the network. An example is the results displayed by search engines, which can serve as a guide to any technical and business users to find the data they need. Another purpose of metadata is to protect resources and its future accessibility. Metadata can provide necessary controls on what should be enforced upon the data and what data should be controlled. It is fairly important given the fragility of digital information and its susceptibility to corruption or alteration. This usually helps with regulatory compliance, retention and archival, security, and service levels. For archiving and preservation purposes, it takes metadata elements that track the origin as well as the physical aspect of the object so it can be used for future references.